Grade 8, Chapter 11, Mensuration, Exercise 11.2. So before moving on to the exercise, let us revise the formula to find the area of a quadrilateral, which is d by 2 into h1 plus h2, where d is the diagonal and h1 and h2 are the altitudes to the diagonal from the opposite vertices or the height. Now, area of a trapezium is h by 2 into a plus b, where a and b are the parallel sides of the trapezium and h is the perpendicular distance between them or height of the trapezium. Area of a rhombus is half d1 into d2, the product of half of the product of its diagonal. But please remember that since a rhombus is a parallelogram, if you know the side of the rhombus and the one side of the rhombus and the height to that, perpendicular to that side, if you know, you can find the area using the same formula of parallelogram, that is base into height, that also applicable to the rhombus. Okay, children, now let us move on to the exercise. Question number 1. The shape of the top surface of a table is a trapezium. You can see it in the figure. Find its area, its parallel sides given, height given. So it's a very, very direct question. You just have to apply the formula. That's all. So parallel sides A and B given, height of the trapezium given. So the area of the trapezium, what is it? Yes, h by 2 into a plus b. So 0.8 by 2 into 1.2 plus 1. So decimals are there. So do carefully. So it's 0.4 to 2.2, 2 decimal multiplying. So the product should have 2 decimal places. That is equal to 0.88 and the unit is meter. So it will be square meter or meter square. So right, now let us move on to question number 2. The area of a trapezium is 34 centimeter square and the length of one of the parallel sides is 10 centimeter and height is 4 centimeter. Find the length of the other parallel side. So what is given here? One of the parallel side given, height given and area also given. So you just have to find the unknown value, that is the side B. So area of the trapezium is 34 centimeter square. In that H we know, A we know, only B has to find. So substitute the values in the formula and simplify. So then from this find out B. Solve for B. So you will get B equal to 7 centimeter. The other side, other parallel side is 7 centimeter. Now moving on to question number 3. Length of the fence of a trapezium shaped field ABCD. So length of the fence, so that means the perimeter of the trapezium is given here and 3 sides length given, and we have to find the area, and here one of the side itself becomes the altitude. AB is the side and it also the altitude. So from the perimeter, we need to find the side AB, or that is the height of the trapezium. We have to find out. Then you have to apply the formula of area. That's all. So perimeter is 120. That means perimeter means AB plus BC plus CD plus AD. All the sides, if you add, you will get 120. So from in that 3 sides we know. So only one side we have to find. So AB is equal to 15 meter. Now we got the height of the trapezium and the parallel sides, which are the parallel sides, BC and AD. So we can find the area of the trapezium by substituting the values. So the area is 660 centimeter square. You can pause the video and note down if you have any doubt. Now next question, question 4. It's a very, very direct question. The diagonal of a quadrilateral shaped field is 24 meter and the perpendiculars dropped on it from the remaining opposite vertices are 8 meter and 13 meter. Find the area. So very, very direct question. Everything is given just to apply the formula. That's all. So area of the quadrilateral, half of the diagonal, d by 2 into h1 plus h2. So apply it. So that's it. Simple solving. That's all. 252 meters square. That's it. Now question number 5. The diagonals of a rhombus are 7.5 and 12 centimeter. Find its area. This is also a very, very direct question. The two of the diagonals given. So what's the formula, children? Yes, area of a rhombus is half d1 d2. Just apply the values. That's it. Yes, so it's equal to 45 meters square. Very, very simple and direct question. Now next one. Sorry, here it is centimeter square, 45 centimeter square. Next, find the area of a rhombus whose side is 5 centimeter and whose altitude is 4.8 centimeter. And if one of the diagonals is 8 centimeter long, find the length of the other diagonal. So what we have to do, it's a base and altitude given. So as I told you in the beginning, rhombus is also a parallelogram. So we can apply the formula of finding the area of a parallelogram, that is base into height, to find the area of a rhombus also. So B into H. So the area is 24 centimeter square. Now we got the area, and if one of the diagonal is 8 centimeter, one of the diagonals, say D1 is 8 centimeter. So again we will apply the formula to find the area of the rhombus in other way. That is half D1 D2, which is equal to 24. In that D1 is given. So substitute the value and find D2. So what will be D2? D2 equal to 24 by 4, that is 6 centimeter. Next question. The floor of a building consists of 3000 tiles which are rhombus shaped, and each of its diagonals are 45 centimeter and 30 centimeter in length. Find the total cost of polishing the floor if the cost per meter square is 4. Here one thing you have to note it down. The dimensions of the rhombus is given as centimeter, and we have to find the total cost at the rate of ₹4 per meter square, that we have to find. So first let us find the area of one tile. So half D1, D2, both the diagonals are given. So find the area, which is equal to 675 centimeter square. This is the area of one rhombus. So what will be the area of 3000 tile? One tile area is this. So 3000 tiles, their area will be into 3000. So this much big centimeter square you will get. 2025000 centimeter square. And as I told you, we want the convert it into meter square. So how will you convert centimeter square to meter square? We know that 100 centimeter equal to 1 meter. So to convert centimeter to meter, you need to divide by 100. But here it is centimeter square. So to convert centimeter square to meter square, you need to divide this by 100 into 100. That's the important point. Should not forget. You have to divide 100 by 100. Similarly, if you want to convert meter square to centimeter square, then what you have to do? Then you have to multiply 100 into 100. So do remember this. So this is 2025 by 10. So it will be 10. So one decimal place. So 202.5 meters square. That is the total area of the 3000 tiles. Now let us find the cost of polishing the floor. So it is at the rate of ₹4 per square meter. Very low rate is it? Yeah. So ₹800. I don't know whether now it is possible to this price. I don't know this may be a very, very old book. No, the version is very old. That may be. Okay, anyway, we have learned the concept very well. So the amount is ₹810. Hope you understood. So let us move on to question number 8. Mohan wants to buy a trapezium shaped field. The figure is given. Its side along the river is parallel to twice the side along the road. If the area is given and the perpendicular distance between two parallel sides is 100 meter, find the length of the side along the river. Length of the side along the river that we have to find. So that is A. Let us consider the length of the field along the road A, and it is given that side along the river is parallel to this side along the road and twice it. So what will be the side along the river? It will be, what it will be? 2A. Yes. So now height given, area of the field given. So let us substitute this value and solve for A. So area of the trapezium given. So substitute the values. So A plus, instead of B, we will put 2A. So A plus A, 2A, 3A. A plus 2A is 3A. So 50 into 3A equal to 10,500. So what will be A? 50 and 3 will go to the other side. So I didn't multiply 50 into 3 equal to 150 because again I need to simplify now. So put it like that and simplify. Always cut and do. So we got A as 70. Now what will be B? B is double of it. So the length of the side along the river is how much? 140 meter. So next question. Question 9. The top surface of a raised platform is in the shape of a regular octagon as shown in the figure. Find the area of the octagonal surface. So to find the area of a polygon, there is no formula for that. What we can do is we can split it into different triangles, rectangles, square, trapezium, and then we can find the area of each one and join. That is the method. So here, since it is a regular octagon, now you can see two trapezium here. On the top and the bottom, you can see two trapezium. Both are symmetric, both are congruent. And in middle, you can see one rectangle. So the area will be area of these two trapezium plus area of the rectangle. So one trapezium you can find. So area of two trapezium is 2 into area of one trapezium. So height is 4 and the parallel sides are, what are the parallel sides? So it is 11 plus 5. How this 5 came? The one side is 5. All the sides regular, no? So all the sides will be 5. So this also 5. So 11 plus 5. So it is 64 meters square. So this is the area of both the trapezium is together 64 meters square. Now let us find the area of the rectangle, which is equal to length into breadth, that is equal to 55. Now the total area of the regular octagon is equal to 64 plus 55, which is equal to 119 meters square. Now move on to question number 10. There is a pentagonal shaped park as shown in the figure. The first figure. For finding its area, Jyoti and Kavita divided it into two different ways. That figure is given. Find the area of this park using both ways. Can you suggest some other way of finding its area? So let us first find the area as per Jyoti's diagram. So the dimensions, these two parallel sides are 15 and 30, and this total is 15, so half of that will be 7.5 meter. So the area, the total area will be area of both this trapezium. So they are equal. So one trapezium only you need to find. So 2 into area of trapezium, which is equal to, substitute the values. So on solving, we will get 337.5 square meter. Now let us find the area as per Scavidas diagram. In that, what you can see, one rectangle and one triangle. So what are the dimensions there? all the sides 15. And what will be the height? What will be the height of the triangle altitude? See, total is 30 and this is 15. So from here to here, that means the altitude of the triangle, that will be 30 minus 15. 30 minus 15, which is equal to 15. Now let us substitute the values and find area of square plus area of triangle. So area of square is, we know, side into side, and triangle half BH. Substitute the values and again you will get the area, same area you will get. Now can you suggest some other way of finding its area that you have to suggest, children? Try it out. Now the last question. Diagram of the adjacent picture frame has outer dimensions 24 into 28 and inner dimension 16 into 20. Find the area of each section of the frame if the width of each section is the same. So when you see the frame, you observe, you can see that they are all trapeziums. Yes, but the height is not given. The height means the width. It's given that it is same. So width here gives same. So we need to find that width. So how we will find the width? See here, this is the width of one side. So how we will find? See, total up to this outer length is 28, inner length is 20. So if you subtract it, you will get the length of remaining these two parts. They are equal, no? So it is 28 minus 20 divided by 2. That is 8 by 2 equal to 4 centimeter. Understood it? The same way, the other side, if you do, then also you find the width. Here, this is 24, this is 16. So the difference will be equally divided into this part and this part. So there also you will get, because it's given that the width is same. So 4 centimeter. Now let us divide it into 4 parts. 1, 2, 3, 4. So what we have to find? Find the area of each section. So first let us find the area of trapezium 1. Here trapezium 1 and trapezium 2, they are same, they are congruent. And trapezium 3 and trapezium 4, they also have the same measures. So let us find. Area of each section of the frame equal to area of the trapezium 1, 2, 3 and 4. Trapezium 1, substitute the values. Height we know, the parallel side will be the inner and outer length. So 8 centimeter square. The same will be the area of trapezium 2. Now trapezium 3, substitute the values. And the same will be the area of trapezium 4 also. So we got the area of each section of the frame. So that is the end of this exercise 11.2. See you with next exercise soon. Till then, bye.